So we move now on the biggest icy satellite, Ganymede. Ganymede has an icy crust of approximately 100 kilometers and a subsurface salty ocean whose activity allows the induction of a known magnetic field. And then at depth, it is characterized by a high pressure ice mantle. Ganymede is also the satellite of our study area for the mapping activity of this afternoon. So I will now introduce its geology at global scale and the main terrains and features that you could identify in your study area during the mapping exercise. So Ganymede has been imaged mostly by Voyager and Galileo missions that globally cover the surface, its surface, and allow, of course, to produce a global mosaic based on images in the visible light that show two main terrains that characterize the icy surface of Ganymede, which are the dark terrain and the light terrain. So such global mosaics has allowed to visualize and detect geological units. As for Europa, structural features that characterize the surface whose global compositional characterization has been detected also in this case thanks to the data from the NIMS spectrometer of Galileo mission. And so also in this case, for Ganymede surface spectral models allow to produce compositional maps of the surface of Ganymede. That is, of course, mostly composed by ice and also other compounds, other materials. This map shows the best estimate of water ice abundance, which is highest in the younger light terrain and around impact craters. While the occurrence of water ice is low at the dark terrains that are composed by low albedo material whose nature is still unknown. But the surface of Ganymede shows also other components that characterize it, and thanks to spectral models, it has been possible to estimate also abundances of, for instance, acids, salts, and spectrally flat darkening gadgets. So this is the example of the estimate of global abundance of hydrated acid that differ also in this case according to the location and show higher abundance that occurs in high latitudes. And also such estimates show differences among the main terrains, and therefore, so we come back to the base map and the global mosaic of Voyager and Galileo, which has been used for other geological implications that use the base. This mosaic as base map for the production of a global geologic map that subdivided the terrains into units according to their albedo, crater density, and structural features. So the main terrains are two, and are dark terrains here on the map in brown, and the younger light terrain here in the global geologic map in green, light blue. And according to crater densities, the dark is the oldest terrain on Ganymede, on the surface of Ganymede. And the areas where dark terrain is located are called region or regions, while the light terrain is the youngest terrain on the surface of Ganymede. And it forms a very complex and intricate patchwork across the surface called that formed areas called sulcus or sulci at plural. And so both terrains are subdivided into units. The dark is subdivided into the dark cratered unit, lineated unit, and undivided unit. This is an example. Here it is shown an example of lineated unit that always occur adjacent to light terrains and often shares similar characteristics and have a common structural fabric with the light terrain units. So this implies that the tectonic forces that modify the dark lineated terrain, the dark lineated unit, are related to the same forces that form early light units, and so this is why such dark lineated unit is assumed to be something similar, a precursor, something similar to a precursor for light material. And instead, on the other hand, the light terrain has been subdivided into other units, which are the main ones is the grooved units, then also the subdued units, and then the irregular and undivided units. And on the right here, there is an example of two light terrain units, which are the grooved and the subdued units. The grooved unit is mostly characterized by tectonic structures called grooves. Grooves indeed characterize a lot also other light terrain units, but mostly dominate the grooved unit. And on the other hand, the subdued unit is arranged in polygons similar in a similar manner of the light grooved terrain, the light grooved unit. But it is characterized by a smooth surface with also in this case with groove structures, but that are more faint or undetectable at the kilometer resolution. And the interpretation of such of the terrain formation of Ganymede suggests that the dark material is composed by of a relatively thin lag deposits of non-ice material. So what we observed on the spectral models of the surface of Ganymede, so it's a low albedo material, sorry, that mostly concentrates on surface and overlies lighter icy material. And on the other hand, the light terrain, the formation of the light terrain is connected to resurfacing processes that infilled with new, fresh, and light material the topographic lows. So the formation of the light terrain is strictly related to extensional activity that allows the resurfacing of the deeper material, fresh and deeper material. So both terrains show surface features that are related to deformation and tectonic activity or impact cratering. So the dark terrain is mostly characterized by structures called furrows. Furrows are fragments of trough that are regularly spaced and arranged with a radial or circumferential setting. And such structures represent the remnants of a null multi-ring impact basin that produced such circumferential sets of structures. And on the other hand, as I mentioned, the light terrain is strongly deformed by tectonic structures called grooves. Grooves are linear to curvilinear kilometric scale fractures and folds and cracks with that show a very complex setting. In general, such structures, grooves, have been interpreted both as extensional and strike-slip structures, since, of course, they show characteristics of both tectonic regimes. And as the other planetary bodies, the surface of Ganymede and mostly the dark terrain of Ganymede is characterized by craters and also palimpsests. Palimpsests are circular to elliptical features with smooth or also hammocky texture and an albedo that is relatively higher than the surrounding dark material. So palimpsests are interpreted to be the result of impacts in the crust of Ganymede in the past, during a time where there was higher thermal gradient or a thinner brittle crust, brittle lithosphere. And unlike craters, palimpsests lack rims, but often they can show internal rims structure. And other features that have been recognized on the surface of Ganymede are the paterae, which represent depressions that have been interpreted as features similar to caldera, volcanic caldera